Alright, can you please confirm if this image it is clearly visible to me? Is it somewhat blurred? Okay. Okay. Let me check. Write the data then. Alright, so meanwhile, I will draw this data table and we continue today's session. We have discussed about few algorithms as of now. We know about linear regression, we know about logistic regression, and we know about decision tree. Now, firstly, tell me to which category of learning these algorithms belong. Is it supervised learning or is it unsupervised learning? Write in the comment section, please. Okay, supervised learning. Yeah, correct. Now, if I have a classification problem, which algorithm from these algorithms I can use to make predictions upon a data that has a variable which is of categorical nature? Logistic and apart from logistic, apart from logistic, there is one more algorithm from these that you can use for the same. For what do you use decision tree for? Yesterday we did an implementation using decision trees. Can you please recall what was the target column? Am I audible to everyone? Please give a thumbs up if I'm audible. Then please answer the question. For which kind of problem we used decision tree yesterday? Yeah, we can use decision tree for classification problem. And can it be used for regression problem? Yeah, please let me know. Can it be used for regression problems as well? Okay, Paras thinks that we can't use it. Anyone else? Okay, no. Decision tree can be used for regression as well as classification problems. When I demonstrated the decision tree for classification data, we for categorical data, we used decision tree classifier function to create the model. And at the same time, I was telling you that if this problem was of regression, then instead of this function, you would use this decision tree regressor. Okay, because you can use basically you can apply decision tree in both kinds of data, whether it is a classification problem or a regression problem. In the example as well, um, firstly, I defined you the example of, I think, based upon occupation and based upon someone's gender, we were categorizing people based on what was the data. I think it was yeah, what was the app that should be recommended. Okay, so here the split they were happening based upon the gender column and the occupation column. But in the iris data set, we used sepal length and petal length to make the splits. Okay, so decision tree it can be used for both the things. Linear regression is only for regression. Logistic regression is for binary classification. Okay, now can you tell me what is sigmoid and what does it do? Yeah, please tell me what is sigmoid and what does it do? Please give a thumbs up if you don't remember. Yeah. So sigmoid is a function, okay, that transforms the data such that you get a probability between 0 and 1. Okay. And based upon these probabilities, you can decide to which class your data is belonging. Okay, so this sigmoid, it is responsible to transform the data into in form of probabilities. Okay, all right. So we know about logistic regression, we know about linear regression, and yesterday we saw the implementation of decision tree, but we could not see uh, how the decision tree was made, what was the internal computations that were happening. So, are you guys ready for it? Please give a thumbs up if you are ready to understand how decision tree works. Basically, you know how they work, but how you can split the decision tree. Okay, so let's start with it. Now, we talked about two things. One thing is called Gini, impurity, and other thing is called Gini entropy. Now, decision tree, they are also there is another factor that is called information gain. Okay, these two things, impurity and entropy, they are kind of very similar. Okay, now the only difference that I find between them is their formula. So I'll just put up the formula for Gini. If I write, this is the formula. So 1 minus probability of I whole square. Let's just write it in a better manner. 1 minus sum of probabilities. Okay, and square of such probabilities. So this is the formula for Gini. And if I write the formula for entropy, this will give me a moment. So instead of it is summation of all the probabilities. Just a moment. Okay. So it is summation of probability at BI and log of the log base 2 and the single element. Okay, so this is the formula for entropy, and here the sign is negative. This is the only difference between G and entropy. Now, yesterday when I was explaining the implementation part, I told you that entropy is it is the measure of randomness, or we can also say disorder. Now, here in this particular data, if you observe, say, let's just say label is our targeting. Okay. And if all the labels, okay, all these labels, they belong to the same class, then we would say that entropy, it is 0. But right now you can say that you can definitely see that labels, they belong to different classes. So entropy, it is not going to be 0. It is going to be somewhat between 0 and 1. All right. So it is what? It is the measure of disorder. Now, what we want to achieve when we like split the tree based upon Gini or based upon entropy, we split the tree till we get entropy or impurity equals to 0. When we achieve this, we basically conclude that no more splitting can occur because we have achieved, like when the value of Gini or entropy equals to 0, we believe that we have achieved maximum separability and we have formed pure classes. Okay. So these two things, they are like quite important while considering decision tree. Now, when you look at the formula here, we are calculating the square of the probability, whereas here we are computing the logarithm of the probability. So if we talk about computation wise, Gini makes faster computation. So apart from this difference that their formula is different, uh, there is one more difference between the two, that is with regards to computation. Since here we only have to compute squares, but here we have to compute the logarithm of the probability. So if you're working on a very large data, I told the same yesterday as well. So if you're working on a very large data, it is better that you use Gini. And in decision tree, by default, the criteria is also Gini. Alright, please let me know if everything till here is understandable. You guys understand that these are two things based upon which we can split the decision tree. These are their formulas and what do they mean. Please give a thumbs up if you understand. Anyone else having any doubt, please write in the chat box. Okay, so n- nevertheless, let's use this data and let's form a decision tree. Okay, let's see how the decision tree is going to split. Okay, and then it will be much more easier for you. So this is going to be a little bit mathematical and it would require some attention from you guys. Okay, it might also turn boring after a time, but if you understand it, you'll understand decision trees. Okay, so here you can see that we have the data. Okay, so we have color and diameter, and let's say based upon, is this color okay? Can I use this green color to write? Let me use a darker shade. Okay, yeah, it would be better. So we have these two columns, X color and X1, and let's call it X2, and we have this target variable Y. Let's say what I want to achieve based upon X1 and X2, I want to predict Y. Okay, so for color and diameter, we are telling what is the label. Do you get it? So here, one thing that we did yesterday, we would look at the label and we would start dividing the data, right? And that was quite easy for us. But I also told you that if the data is quite large, then it is not possible to just look at the data and start splitting the tree. Also, here you can see that I have two parameters. I have color and I have diameter. How should I decide which parameter should be at my root? Can I split upon based upon color? That should I ask question about color? Whether color is red or yellow. So in color as well, I have how many? I have three things that I can ask. So how to decide which thing to put at node and what is the question based upon which I should split my tree? I can use diameter equals to 3. I can use diameter equals to 1. So many things can be done. So for that, we have these three quantities, Gini impurity, Gini entropy, and information gain, which are going to help us out to split the tree. Okay. So what do we do? Since entropy is a very widely used measure, sorry, not entropy, Gini impurity. It is very widely used measure. So I'm going to use Gini impurity to split the tree. Moreover, the technique that I'm using, it is called card. I told you that there are few algorithms which uses decision tree for the implementation. There is CART, there is ID3, and there is C4.5. Okay. So CART is one such algorithm that can be used to construct a decision tree uh, basically efficiently. The full form of this thing is called classification and regression trees. So doesn't matter if you have a classification problem or you have regression problem, you can use CART to draw a decision tree. Okay, so let's decide how to draw it. Now, first thing that I would like to write here, this is step 1. Whatever feature produces least impurity, that will be selected to split the tree. Okay, so right now I have two features. I have color and I have diameter. I'm going to calculate the Gini impurity for the two. And whichever feature has the least Gini impurity, I'm going to consider it as the splitting criteria. Do you get the drill? Please give a thumbs up if you understand. Okay. Now let's calculate Gini impurity if color is at node. Okay. So you guys understand this thing now? What is node? The root node is the topmost node. Then we split the tree and we have decision nodes. And when the split is not possible, those nodes are called leaf nodes. Okay. So I'll just draw a simple diagram. So this is the root. This is decision. And after these, we are not splitting the tree. So this is leaf. This is also leaf. And if this one has one more child, let's say, so this is also the leaf node. Okay, this is also the decision node. So here we are going to see what should be this value. Okay, what should be the feature based upon which I'm going to split. So firstly, we are going to consider if color is at the node. Okay, so let's calculate the Gini for it. Now we know by looking at the formula that for this purpose, I need to calculate the probability. Okay, and then I need to sum the probability, get the squares, and I need to subtract it from 1. Okay, so let's see how to expand this formula. So firstly, I'm going to do it for color equals to green. I have 3 colors, green, yellow, red. Now please go to the data and see how many colors are there. So we have 5 colors, and out of these 5, only one is green, right? So the probability of a label being green, it is 1 by 5. That is 0.2. Then we will check the probability for color equals to yellow. Go to the data again, and here we will see that there are 2 labels for yellow out of 5. So the probability for a label being yellow, it is 2 by 5. That is 0.5. And similarly, let's calculate for red as well. So color goes to red. And we have 2 labels which belongs to red. Again, the probability is 0.6. Please give a thumbs up if there is no doubt till here. This is quite important, so please pay attention. All right. So here, what we are going to do, we will now calculate the impurity. Okay. And how to calculate the impurity? 1 minus sum of all the probabilities. Right. So what do? We subtract 0.4 whole square, 0.2 whole square, and 0.4 whole square from 1. Right? We are going to do this. Now, can you please compute it and tell me what would be the result? Please compute it and tell me what would be the result. Okay, so it would be what? It would be 0.64. Please keep this value in mind. We will come back to this value. Okay. So this is done. If color is selected as the feature, then this would be the impurity. But we are not done with it. Now we are going to see if, okay, we are going to compute, let's select a different color. So we are going to compute for each color, we are going to calculate the probability for a specific label. Okay, basically, if color is red and label is mango, what is the probability? If color is green, label is what is the other fruit? Lemon, what is the probability? So we are going to do that. So let's do it. And I'm going to first check if, like, probability, if color equal equals to, let's say, green, and label equals to mango. Okay, now let's go to the data and check. So, please observe the data and tell me how many labels are there where the color is green and the label is mango. The color is green and the fruit is mango. Right, only one label. And for the green color, I don't see that there is any other label for any other fruit. So we are going to consider that out of a sample space of one, there is only one occurrence. Okay, for the green color where the fruit is mango. So the probability would be one for this. This is the second part of this demo. Okay, then let's do the same. So we are going to calculate probability if color equals to yellow and label is lemon. Let's go and check. So we can see that here we have two colors, two records where the color is yellow. And we have only one label, one record where the color is yellow and the label is lemon. So the probability would be computed as 1 divided by 2, that is 0.5. Because total we have two yellow colors in the color column, but there is only one label, one record which satisfies this condition. So the probability would be 0.5 for this. Okay. Now yellow color, it also has another fruit which is mango. Where, so here it is lemon and here it is mango. So let's calculate if color is yellow and label is mango. So again, the probability would be what? 1 by 2, that is 0.5. Once this is done, for this color, we are going to calculate a Gini index. We have to calculate it for green as well. So what would be Gini index? Gini index is basically their individual probability. The formula is same. 1 minus probability square. So 1 minus 1, 0. This is the Gini index for green. And for yellow, did we calculate? So Gini index 1 minus, and what is the probability here? So it is 0.5 whole square minus 0.5 whole square. Summing all these probability and subtracting from 1. This would give 0.5. So this is the Gini index for yellow. All right. Okay, now last and the least, we are going to calculate for red. Color equals to red and label equals to grape. So let's go and check. Where is the data? Yeah. So we have two instances for red color, this one and this one, and both of them has the label as grape. So probability would be 2 by 2. So 2 by 2 would be the probability for the same, that is 1. And Gini index for red would be 1 minus 1 whole square, which would be 0 again. So this gives me the Gini index of all. And in the previous sample here, we had calculated the individual probability of the color. And here we have calculated color along with label. So now what we are going to do, we are going to calculate weighted Gini impurity. Okay, so this term weighted, it is going to come at various instances in machine learning. So you can associate it with priority. Okay, so here in the data, we can see that not all the labels are equally distributed. We have that red and yellow, they are occurring twice, whereas green, it is only occurring once. So weighted means that you are multiplying, not only you are considering these probabilities that you just calculated, you are also multiplying their individual occurrences. Okay, and doing that, you are giving priority to the label which is occurring more number of times. Do you get it? Why is it necessary? Just like while we were discussing about the random module, I gave you the example of the roulette wheel. So roulette wheel, it has green and it has some black pockets and it has red pockets as well. So if a roulette wheel has 32 pockets, it 32, so it would be having, let's say 34 pockets are there. So it would be having equal division of pockets for green and black and two for red, let's say. Okay. So here, if you have to create a model or if you have to create a function which would like randomly select where the ball is landing, on which color pocket the ball is landing, you would have to assign more priority to green and black and less priority to red. And we are doing the same here. While calculating the Gini impurity, weighted Gini impurity, we are multiplying their priority, which is directly associated with how many times these things are occurring to calculate it, to calculate a weighted Gini impurity, basically aggregated or average. So we know that for red, for green, it is 1 by 5. Okay, out of 5 labels, we only have one green. The Gini index that we calculated for green, it is 0. We will add to it the probability of yellow, that is 2 by 5. And what was the Gini index that we calculated? It was 0.5. Then let's do the same for red. So the probability is 2 by 5 and it is 0, the Gini index. Please compute it and let me know what is the answer. Okay, the answer is 0.5. Now this is the whole computation that we did for one feature. Okay, and what was our feature? It was color. We will do the same for diameter as well. Now, I'm not going to demonstrate it because it will take lots of time and it will simply bore you guys out. But in the same manner, we will compute the impurity, weighted Gini impurity for diameter as well. So for color, we got it 0.20. And for diameter, I have calculated it. Let me check what we will get. Yeah, so for diameter, we'll get it 0.26. Finally, we will select the feature that has the minimum impurity. So Gini impurity of color, it is less than diameter. So this is going to be my splitting criteria. Okay, so this basically right here. So I got to know that red, sorry, not red, just a minute. I not got to know that color would be my splitting criteria at the top. Okay, now there is another thing. In color as well, we have red, we have green, and we have yellow. That we got to know that color is going to be the splitting feature. But what is the question that I should ask? Should I ask if something is equals to green, is it equals to yellow, or it is equal to red? So we calculate another thing which is called information gain. Okay. So information gain, just like impurity. Whenever we calculate impurity, we choose the feature which has minimum impurity. Information gain is basically used to select which part of the feature should be used to ask the question about the decision mode. Okay, whether to split based upon red, green, or yellow. And for information gain, basically it is believed that this is the value which is directly telling you what is the information. Okay, what is the knowledge that you have related to the feature. Okay, and if information gain for something is more, that feature will be used to split the tree. Okay, that basically that part of the feature will be used to split the tree. So what we are going to do, information gain formula is I parent minus probability of the information gain of the left subtree 1 minus probability multiplied by the, just a minute, let me slide it, information gain of the right subtree. Okay. So basically, what do you do? use put all the colors at the top one at a time. So let's say firstly I choose for red. Then what do I do? If the color is red, then there is going to be splitting for my color. And if this is true, let's say this is for false and this is for true, then I would be getting a left subtree and I would be getting a right subtree. Okay. So based upon these trees, okay, what would be the value? So if color is true, then there could be only one thing. Like if we go back right here. So if the color is red, there is only one possibility for diameter and one possibility for uh, label. So if this is true, then what do we do? We are going to simply say that the color is, sorry, the label is green grape and the diameter is 1. But if it is false, then we are going to check whether the color is green, right? So based upon if I put red at the top, I'm going to get some left subtree and the right subtree. So I'm going to repeat these steps for this situation where I'm getting the left subtree and the right subtree. Calculate the Gini, calculate the weighted Gini, and then I'm going to compute this particular formula. And for whatever feature, for red, green, or yellow, for whichever feature my information gain is max, that will be used to ask the question in the node. Okay, should I calculate and tell you guys how to do it? Information gain. All right, so just a moment, I'll tell you. Okay, we won't be diving into much more complexities, but if I calculate it, you'll get an idea about it. So what we are going to do, we need three things for this. We need Gini, right? We need Gini left. Okay, for the left subtree, for the right subtree, and we need Gini of the parent, right? For parent, we have already calculated the Gini. I'll show you where here. This is the Gini impurity for the parent because this is for what? This is for all the colors. So this we have got 0.64. Now here we need to subtract the impurity of, yeah, just a minute guys. Yeah, we have to subtract the Gini impurity of the left subtree and the right subtree. So let's calculate it. So Gini right, we are going to calculate it by 1 minus, and for the right what would be the case? So again, there would be two possible labels. Both of them would be red. So this would be the probability. So you are going to compute it 2 by 2 whole square. Because if we are like commuting or traversing the right tree, there is only one possible label, which is red. So we have two such cases, and both of them are red with label equals to grape and diameter equals to 1. So this is going to be again 0. Let's calculate for the left subtree. So for left subtree, there could be two cases. Either the label could be green or it could be yellow. So for green, like total, if we go back, yeah, right here. Let me take a highlighter. Just a moment. Yeah. So here you can see that we have green, we have yellow, and we have yellow. So in total, we have three labels. If we traverse through the left tree, so these three labels, two of them, one is green and two are yellow. So what would be the Gini for this case? Gini for the left subtree. This one, it would be 2 by 3 and 1 by 3 would square. Can you all compute it and tell me the answer? Please compute and tell me the answer. Okay, so for this we get 0.44. And Gini of parent we already have 0.64. So let's put them all in the formula. Okay. So for left subtree, what do we get over here? We get 0. This is 0. This is 0.4. I think I'm missing something. Let me just check. Yeah, we need to multiply the overall probability as well. So 3 by 5. This is the probability for the left tree. And this is what we got as the calculated probability for 0 for the left tree. And for right, we got it 0. So no need to mention that. And if we calculate it, we'll get somewhat equal to 0.37. Okay, so this is the overall probability, and this is the probability of the left tree that we got. For right, it is 0, so I'm not adding that in the formula. And this is the information gain. Sorry, this is the information gain if color equals to red. Okay. Similarly, we will calculate for color equals to green, for color equals to yellow. And I have computed it. So this would come around 0.14 and this would come around 0.176. And since information gain for red is more, so we will be asking the question about red. So the split would be happening based upon color. And the question would be asked whether the color is red or not. And then the tree it would split. And these similar steps, they are carried out throughout the tree. Okay, so these steps, they recursively occur in order to split the tree. And once you get impurity equals to 0, okay, so that means that no further splitting should occur. Here we know that there is only one label. There is only one case, basically, grade 1, and we have two such labels for that. So for this particular part, if you are going to calculate impurity, it will be computed to 0. Okay, now please tell me if you guys understand the crux of information gain, Gini impurity, decision tree. In the same manner, you can use entropy to split, just change the formula. Anji, please bata dijiye if you understand. Everyone else, Ziaul, Vartika, Mothra, Shivam, Bharat, Goel, Vanshu, do you guys understand? Like, thoda bahut bhi, if you are understanding that, that's also good for this lecture. Yeah, you require to see the recordings and see math is like parallel to machine learning. So whenever we'll be talking about algorithms, we will be talking about maths. But one thing that I can assure you that since you all are developers, okay, so while we create machine learning models, we have functions, we have tools to like render these machine learning models. So at that time, it is not itna important to know how these things are happening internally. Basically, if in the beginning you have an idea how these things are happening, it would be giving you a frame of reference, what to use, how to use it. Okay, basically you won't be simply applying a vague idea. That to say. And these mathematical calculations won't be a burden at that time. But in the beginning, it is necessary to understand so that you know how things are happening internally and how to improvise the model. बाद में you guys can forget it. Okay, it doesn't matter. You just need to know how to implement the model. And for that, you need to know what are the functions. Those functions also, they can be searched on Google. You can ask ChatGPT. You can read the documentation, various resources, and how to improve the accuracy. And those things you will understand once you start the coding and you gain hands-on experience. Okay, every one of this thing, it is like very secondary. When you get the hang of how to develop a model, उस time पे you will also get the understanding that when to use Gini, when to use entropy. Okay, without having to worry about the maths behind it. So whenever I come across any algorithm and whenever I come across any class for related to machine learning, people are very afraid by mathematical aspects of it, and I'm one of those people. But believe me, over this journey, you will feel that this is very secondary once you have understood it, and if you know this, basically client को इससे मतलब है. This is just for your understanding so you can perform this. Okay. So I hope that all of this conversation has eased you a little bit. Okay. अभी के लिए समझ लो, later on you can ignore it. Okay. Now I'm not saying that this is not important. Later they will be like uploading these recordings on YouTube as well. So I don't want to hurt the sentiments of people who are going to think that math is important. It is important. But later on you will feel that it is quite secondary. Okay. If you know this. All right, let's take a 2 minutes break. We will see the implementation of random forest. I've talked a lot today. And after the break, we will see how to implement random forest. Okay, 2 minutes break then. All right, guys. And please give a thumbs up if everyone is present here. So let's talk a little bit about random forest. Yeah. And then we will see the implementation. So random forest is not much different than decision tree. Basically, decision trees, they are the core structure of random forest. Just like if we have bunch of trees together, 100 and 200 trees, we will call it a forest. Similarly, we have another algorithm that is random forest. This algorithm as well can be used to perform classification as well as regression tasks. Because decision tree can do so, so random forest can also do that. Now, what is the idea behind a random forest? Okay, so there is one thing that is called ensemble learning. So what does ensemble learning means? It simply means that training multiple models at a time. Now you guys are well aware that these computations, training a model and handling optimal results, it can be a time consuming process. And if I have to train only one model at a time, it can be like taking lots of resources and lots of time. So basically, ensemble learning, it comes with the concept of training multiple models at the same time. Okay. Now, what is the need of training these models? So basically, decision tree, it has some disadvantages. Now, as of talking about the advantage, I have already told you that these decision tree, basically, constructing a decision tree is quite similar to like our thought process. Like we make decision. Basically, every time we ask a question whether to do this or do that. So that is quite easy. So it becomes easier for us to understand decision tree if we take out the maths. Okay. Then since everything you are able to observe that what is happening at each step, it becomes kind of graphical and easier to comprehend. So if I have a client, if I want to tell what are the internal details, what are the internal computation, I can use a decision tree, and it would be easily explanatory. Now, talking about the disadvantages of the tree, basically they are not accurate. Now, ideally, when you like talking about accuracy, if you like traverse through a tree, if you go to the bottom nodes of the tree, impurity or entropy, whatever criteria you are using, it should decrease. Okay, because we are going to stop the construction of the tree when impurity or entropy would be equals to zero. So ideally, like level by level, this impurity it should decrease, but that is not the case. You can implement any model, and you will see that sometimes it will decrease and sometimes it will increase. Similarly, information gain as well. So information gain it should increase while we go down the tree, but that also does not happen quite often. So accuracy it is a major factor that comes under the disadvantage of decision tree. Another thing that I want to talk about here is that decision tree, they are very susceptible to changes. So if I change my data, okay, if we change the data by a very small fraction, okay, one or two changes I have made to the data, not one or two, but basically very less as compared to the data that I have. The tree structure will change and it will change by a massive difference. Okay, so basically these are few of the advantages, and you can write one more advantage here that they can be bias. What does bias means? Bias means some kind of error or some kind of favoring. So it can favor some classes and it can completely ignore other classes. Again, this would impact the accuracy of the decision tree. So here, because I have these advantages, these advantages, I should think of a model that should be able to resolve all of it. Okay, decision tree is advantageous, but I want to resolve these disadvantages. So for that, we have random forest. Now, what random forest is? It is multiple decision tree. So I can have a decision tree like this, and I can have a decision tree like so. Okay, so for my data, I can have n number of decision trees. Okay, and then I can have output one from this, output two from this, and let's say output three from this, and I can aggregate all of these output and get one single output. Okay, so this is the whole idea behind random forest, and this is what is ensemble learning. So here, what I'm doing, I'm training parallelly. I'm training multiple decision trees together. Now, this tree, it will have some of the disadvantages. Okay, which bias I bias. Similarly, this will have also some bias. This will also have some bias. But what we are doing, we are not considering the output of one single tree. We are aggregating all the outputs of all of these decision tree models that are trained parallelly. And out of these outputs, we are selecting an aggregator like that. One that is coming in most of the trees. Okay, the most voted output, that is to say. So doing this, I am minimizing the error. I'm maximizing the accuracy of the decision tree because now I have combined multiple models which were not performing well individually, but altogether they are providing me the correct output. All right. Now this ensemble learning, it has two kinds of type. We have something called bagging, and we have another thing that is called boosting. Okay. So bagging is what? Bagging is what random forest is doing. Basically, models, they are trained parallelly. Each model has equal say. Okay, because these models, they are independent of one another. And at last, I'm going to consider the most voted or the most aggregate or the aggregated output. So this is what is happening in batching. Whereas in boosting, here also we are training multiple models, but these models are trained sequentially. Okay, so sequential training means that I might have model one. It gave me some output. That output was fed to model two, model three, and model n. And finally, the output that I get is given by model n. So here what happens? Each model, it works. It works to overcome the shortcomings of the previous model. Okay, so whatever other things that this model is doing incorrectly or not able to do, that would be corrected by model 2. And similarly, sequentially, one after the other, the model improves and generates one single output. Okay. So sequential training happens. Here we can't say that there is equal say, so not equal say. Since the model, they are trained sequentially. So one of the models, okay, which is stronger or which is basically giving a more correct output, or let's say a stronger result as compared to the other models. So that model is going to dominate. Okay. And since we are treating them in sequence, so we cannot say that these models, they are independent. They are dependent. One model is learning from the mistakes of the previous model. And here we get the final output. Okay. This output, it is not aggregated. This is improved over the training. So both of these techniques, tagging and boosting, they are part of ensemble learning. And if we talk about, they are responsible for improving the models. Okay, improving their accuracy and improving their efficiency. So do you get the crux of random forest? Why it is used, how it is used, why we have replaced it with decision tree? Please let me know if you understand. Okay, now there is one thing that you guys are that you don't have to worry about, that is maths, because we have already discussed it in decision tree. The same thing is happening over here as well. So we will straight away jump to the implementation, but that we are going to do tomorrow. Okay. Before we end, I'm going to show you one real life example of decision tree. So this is a game. Just a moment. Okay, I need to disable ad blocker. Yeah. So this is a game that is called Akinator, and it created lots of buzz before, like 3 or 4 years back. Everyone, all of my cousins, okay, I have like 3, 4 year old cousins. They were like obsessed with this game. And what it does, so if I play it, it is going to ask me, basically, I can think of anyone, whether it is an animal, a personality, a celebrity, or some kind of animated character. So I can think of something, and that then this genie, it is going to tell me what I'm thinking about. So let's test it, and I am going to see if it is going to tell me. I'm thinking of Tom from Tom and Jerry, and let me click on characters. So it is going to ask some questions at each and every time. So it says, does your character live in India? So no. Does your character have special powers? No. Is it a real person? No. Is it animal? Yes. Is your character a character? Yes. Does your character have an older brother? I don't know if Tom had Any younger brother? Is it a character from a game? Is your character green? Probably Tom was blue, but I think he was grey. So probably no. अभी यहाँ पे he has asked me that whether your character is blue and whether he has a red nose. So since I said that it was an anime, so right now it is also checking with Doraemon because Doraemon has a red nose. So no. Does the name of your character appear in the title of a TV series? Yes. Is it a grey cat? Yes. Okay. Is your character close to Brad Pitt? Don't know. Probably not. From a Korean boy group? No. Foresee the future? No. Is your character linked with rats? Yes. Okay. So it predicted correctly. And if you talk about Augie also has. Does Augie have a red nose? Yeah, might be. Okay, chalo. So, what is happening here? At each point, it is asking me some kind of question, and these questions are nothing. They are part of a very vast decision trees. Once I answer the question, the model, it is able to segregate the data. When I said that it is a character, so it was now only looking in the data of the characters. It asked me whether it is a person, so it removed the data of all the persons. Then it asked me whether it is a cat, so I said yes. Now it was only considering cats. So this is how it is able to segregate. Okay, so these are some examples. Okay, I'll try to include more of these examples, but like machine learning there aren't much interactive things. In reinforcement learning, we have so many things that we can look over the internet and we can test. All right, so I believe it was a little bit enjoyable and understandable, and I could get rid of you guys of the boring mathematics. Okay, so on that note, we will end the session. But I'm going to ask one thing before we end. Tomorrow is Saturday, and on Saturdays we have 2 hour session. Please tell me if you're going to be present for tomorrow's session or not, because I have to plan accordingly. Okay, Paras will be there. Anyone else from you guys? Paras Goel will be there. Modhvaj will be there. Himanshu will be there. I need at least 5 people. Okay, Abhiraj and Vartika. Okay, then we are having a session tomorrow at the same time from 9:30 to 11:30. Okay, you all can answer the session. Thanks for attending.